Hsing Heavy Industries Corporation is located at the Kaohsiung Science Park in Kaohsiung County, Taiwan. Being established in 1977 as a local machinery company, Hsing has grown to be Taiwan's leading manufacturer of heavy industry comprehensive manufacturing systems. Since 1996, the company has endeavored to develop scrap metal recycling machines to accommodate the metal refining industry's increasing need for raw materials. Hsing's operational expertise includes the design, production, and installation of steel-making plants, rolling mill plants, scrap recycling facilities, electric power plants, and petrochemical facilities. The company has over 200 employees working in a 35,000 square meter facility. Our strength lies in our ability to create customized product designs. Hsing's R&D department can design an entire plant system in accordance to the specific requirements and the geographical features presented by our clients. The R&D engineers utilize CAD and CAM programs for designing our customized machinery. While our CNC processing center is responsible for manufacturing the machinery parts. In addition to computer-controlled CNC lathes, vertical milling machines, and horizontal milling machines, we also use traditional lathes in the production line. The shredding process consists of the following 6 steps. 1. In-feeding. 2. Shredding. 3. Separating. 4. Discharging. 5. Dedusting. And 6. Sieving. Step 1. In-feeding. During this step, coarse metal pieces are loaded into the shredder. Pre-shredded automobiles and other waste steel pieces are first dropped onto the steel conveyor, which then transports the material to the top of the in-feed chute. The 2 retaining sides of the conveyor are made of 25mm steel plates, which are designed to endure the heavy impact of large metallic objects. The inclined chute transmits the metal pieces to the shredder using a double feed roller, or DFR. The DFR features triangular-shaped spikes and horizontal ridges to facilitate traction. It is driven by 2 high-torque, low-RPM hydraulic motors, which can operate in both forward and reverse. The heavy elements of the DFR also render and flatten the scrap metal into smaller pieces. Finally, the feed speed of the mechanism is controlled by a PLC according to the incoming load. Step 2. Shredding. The soul of the entire system is the shredder that decomposes the waste material into even-sized scraps. The metal pieces are struck, ground, and compressed by the rotor, which is composed of wear-resistant liners and hammers. There are grates at both the top and the bottom of the shredder. As the metal pieces are broken down into smaller sizes, they fall through the bottom grate onto a vibrator located beneath the shredder. the operator can manually eject pieces which are too hard to be ground, thereby preventing overuse to the rotor. The shredder has a few special features that are worth mention. Firstly, the anvil liners and the top and bottom grates in the shredder are made of manganese steel. They can also be conveniently replaced when worn out. To facilitate maintenance procedures, the built-in high-thrust hydraulic cylinders can lift the upper housing along with or without the rotor. In addition, should the motor reach its maximum torque potential during a particularly tough task, the couplings between the rotor and the motor will disengage. By disengaging these two parts, the motor will be protected from overworking. Step 3. Separating. During the separation process, the ferrous scraps are segregated from any other materials. The shredded scraps are then carried on a long conveyor from the shredder to an electromagnetic drum, passing through a Z-box along the way. Here, any dust amid the scrap is removed by the suction action of the dedusting system, which is connected to the upper outlet of the Z-box. The scraps then go on to be separated into ferrous and non-ferrous materials by an electromagnetic drum. The action of the drum is so powerful that over 98% of the ferrous scrap is recovered here. Now the ferrous content is ready for the discharging process, while the non-ferrous scrap falls from the drum back onto the conveyor. An additional electromagnetic drum positioned over the conveyor is used to recover the remaining 2% of the ferrous scrap. Step 4. Discharging. The ferrous material may still contain some non-ferrous matter after the separation process. This matter must be removed in order to yield maximum efficiency in the refining process. Any remaining non-ferrous material is removed manually to ensure thoroughness. The scraps will then have the ideal composition and density for refinement and will be ready for melting. Step 5. Dedusting. To maintain a clean work environment, a comprehensive dedusting system removes and collects dust and other small particles generated during the shredding process. The cyclonic dedusting system has two air ducts. One connects with the upper part of the shredder to directly suck out larger particles and dust. These particles are then ejected onto the ASR conveyor. The other duct connects with the Z-box at a point just before the separation system. Where it sucks out fine substances such as fiber, glass chips, and plastic. These particles are also ejected onto the ASR conveyor, then removed to the ASR bunker. The outgoing air is then sucked through a wet scrubber where any dust and fine particles are trapped in a water tank. The dust settles in the water tank and is then removed to the ASR bunker by a scraping action. The clean water is recycled to the dedusting system. while the clean air is discharged through a chimney. Step 6. Sieving. During the sieving phase, the non-ferrous scraps are classified by material type. The scraps first pass through a trommel screen, where they are classified by size. The first section of the trommel screen allows fine particles, usually glass, sand, and dust, to drop into the ASR bunker below. The second section of the screen removes medium-sized non-ferrous scraps, which are sent to the eddy current separator. The eddy current separator separates the scraps into copper, aluminum, lead, zinc, magnesium, and waste. The waste falls onto conveyors below, where it is manually sorted to recover unclassified non-ferrous content. Content that is too large to pass through the trommel screen is transmitted to a separate conveyor, where it is manually sorted for non-ferrous content. The operational heart of the system is located beside the shredder in a 3-story control tower. The first floor houses the control room for the operation of all the hydraulic cylinders. The second floor is the electronic control center. The third floor contains the control center for the motors and the PLCs. It also houses the global operations center of the entire system. Here, the operator can monitor and control the process on a touch-screen panel that features a user-friendly graphic interface. After a brief training session, one can easily begin operating the system. Hsing provides broad-based worldwide customer service that includes everything from installation to technical support. For new clients, we dispatch an engineering team to assist with the installation and testing of a new system. In addition, follow-up technical consultation is always available to our clients through the Internet. Replacement parts and system components are promptly supplied upon request. All parts, large or small, are carefully packaged and promptly shipped to their destination. Hsing has extensive experience in providing comprehensive manufacturing systems to overseas clients. Expansion and development with responsibility is our motto for achieving business success. Hsing adapted a computerized management information system, MIS, for handling orders, material purchases, storage, production procedures, and personnel matters. In 2003, we obtained ISO 9001 version 2000 certification for our standardized quality management. Hsing Heavy Industries Corporation is dedicated to creating a better environment for tomorrow.